Probability is simply a way to put numbers on uncertainty, something we face in every business decision. People routinely say things like 20% chance of rain or 70% chance team A wins, assigning numbers to events based on past experience. That comfort often fades when they are asked to place a real bet on the same event, even if the numbers have not changed. As soon as money or reputations are on the line, people adjust their expectations, often becoming more cautious. This gap between casual statements and committed choices shows how our internal sense of likelihood is not purely mathematical. Understanding this tension is essential in business, where every forecast is, in effect, a statement you are willing to bet on. In this video, we will define key probability ideas in plain language and connect them to how people actually judge likelihood in real situations. By the end, you will see how these concepts help you frame risk, test expectations, and interpret data over time. To talk clearly about probability, we need a few simple definitions. An experiment is the overall controlled operation, like tossing a coin or rolling a dice. Each individual toss or roll is a trial, a single attempt within that experiment. The outcome is what actually happens in one trial, such as heads on the coin or 3 on the dice. The sample space is the complete list of all outcomes that could possibly occur in that experiment. Getting these terms straight makes it easier to describe what we are measuring and avoid confusion when we interpret results for business decisions. Theoretical probability is what we expect before we run the experiment based on how the setup works. We assume all outcomes in the sample space are equally likely and that there is no bias in the experiment itself. For instance, using an unbiased coin for a coin toss or a fair dice in a roll. The probability of an event is then the number of desired outcomes divided by the total number of possible outcomes. This gives us a clean benchmark to compare against what we later observe. In business, theoretical probability represents our planned or modeled expectations, which we then challenge or confirm using real data over time. An event is a specific collection of outcomes that we decide to focus on, based on what we want to learn. For a dice, the sample space might be all 6 faces, but an event could be rolling at least a 5, which includes only 5 and 6 from that space. The power lies in how we define that event, because it encodes the actual business question we are asking. Clear, targeted events, like at least 75% of customers renew contract, or at most 50% of marketing budget is used for social media, give us meaningful probabilities tied to decisions. If we define events loosely, our probability numbers will feel vague and be less useful for decision-making. Vague statements that appear in key performance indicators, or KPIs, often create drift because the event itself might not be clearly defined or correctly measurable. Consider this statement, for example. 60% of employees will have 60% proficiency in their subject matter. Which event is actually being measured here? The 60% proficiency per employee, or 60% of employees being proficient, or both together? How would you measure, track, and compare progress? If the measurement itself is unclear, the outcomes will create even more uncertainty when determining policy. Empirical probability is based on what we actually observe when an experiment is run multiple times. We count the total number of trials, then count how many times the event of interest occurs, and take that ratio. In business terms, this is like measuring the proportion of successful deliveries after watching many shipments. Early on, with only a few trials, the observed proportion can swing quite a bit and may not match what we expected. Empirical probability reflects our observed experience and helps us respect the data in front of us, while recognizing it may still be noisy when sample sizes are small. A simple coin toss example will help visualize the importance of larger samples in probability applications. Consider an unbiased coin, where the theoretical probability of getting heads is 50%, because there are only 2 equally likely outcomes. If we toss the coin just 10 times, we might see only 3 heads, which is 30%, or perhaps 7 heads, which is 70%. As we run more trials, like 50, 100, or even 1,000 tosses, the proportion of heads begins to move closer to the expected 50%. This behavior reflects the law of large numbers, where the empirical probability gradually mimics the theoretical probability as the number of trials grows. For business leaders, the message is clear. Rely less on very small samples and more on stable patterns that emerge with enough data. If you ran an advertising campaign only once, the returns on advertising may not match your expectations. However, if you fail to achieve your targeted returns after a reasonable number of campaigns, then either the trials produced unusually poor outcomes, or your expectations are not aligned with the reality of advertising campaigns to begin with. With a six-sided dice, the sample space includes the numbers 1 through 6, each with an equal probability of 1/6. If we define our variable A as the outcome of a roll, then A can take any of those 6 values. Now suppose our event of interest is rolling at least a 5, which means the event set includes only 5 and 6, 2 outcomes out of 6. The theoretical probability of that event is therefore 2 out of 6, or about 0.33. In a standard card deck, we have 52 possible outcomes of pulling a single card at random. If the event of interest is defined as pulling a picture card like King, Queen, or Jack, then there are 12 such outcomes possible. The theoretical probability of that event is therefore 12 out of 52, or 0.23. If we define getting our desired outcomes as success, we can track the probability of those desired outcomes more closely. The logic behind defining the success is intuitive. When you define success, you automatically define failure. So the outcomes go back to being binary instead of bigger numbers. Even though a dice has 6 total outcomes, once you define success as getting 5 or 6, you are automatically saying that getting 1 through 4 are failures. Similarly, once you define pulling a picture card out of the deck as a success, pulling any of the other cards are all failures of your event. Compare this success-failure setup with the coin toss example. Notice that the only thing that is different now is the probability. For the coin, the probability of success, getting heads, was 0.5, or 50%. In the defined success event for the dice, the probability is 33%, and defined success event for cards yields a probability of 23%. To repeat what we discussed earlier in the video, how clearly you define your event matters, because it will determine specific probabilities for desired outcomes that you are seeking to measure or track. Probability, in its strict form, gives us exact numerical statements as long as we can clearly define the sample space and the events. In daily work, however, real-world outcomes are often messy, and the clean structure behind theoretical probability does not always hold perfectly. That is why it can be more natural to speak about likelihood when we are dealing with observed or empirical data. Likelihood acknowledges that we are using past experience to estimate what might happen, rather than claiming perfect precision. Advanced analyses and probability distributions rely heavily on empirical measurements to connect theory with actual business performance. And as we discussed earlier, empirical observations may not show expected outcomes in the absence of reliable sample sizes or multiple experiments. Thus, here's a tip that can help one adjust expectations and reality with a simple language shift. Anytime you are tempted to use the word probability in business communication, use the term likelihood instead. Probability typically refers to theoretical expectations of success, whereas likelihood refers to empirical observations of success relative to theoretical probability. And if you see a report that is using the word probability when they are referring to observed sample data, know that they are referring to what they estimate the likelihood to be, not the exact outcomes in the population. This simple shift can be very useful in interpreting numbers carefully and strategically while making decisions on the path ahead. Clear probability thinking starts with a deliberate definition of the experiment, the sample space, and the specific event that matches the business question. We must keep the distinction between empirical probability, based on observed counts, and theoretical probability, based on ideal assumptions, firmly in mind. The law of large numbers reminds us that the match between the two improves only as the number of trials grows. So early data should be read with caution. In practice, talking about likelihood helps bridge clean theory and imperfect reality. Use these ideas to frame risk more clearly, explain your assumptions, and make decisions that respect both your expectations and your actual data.